Hey math enthusiasts, welcome to part 2 on the notes on Pythagorean Theorem. So we'll pick up where we left off with example 5. So in this problem they're discussing a rectangle. It has a specific width of 6 millimeters and a diagonal of 12 millimeters. So let's start off and we'll just sketch out our triangle. So here's my width of 6 millimeters. And then my diagonal is going to go from one vertex to an opposite vertex. And I'm told that that is 12 millimeters. Now, the other thing that I know about a rectangle is that all 4 angles are right angles. So I'm going to add that in there. Now, what they want is the length and the perimeter of this rectangle. So I'm going to have to solve for this side. So it'd be the same on the top and bottom because the width is the same on the left and the right. So it's up to you. You can focus on either triangle that the rectangle has been split up into. So let's take a closer look at this one on the bottom left. So I'm just going to redraw it. We have the right angle here, we have 6 millimeters here, 12 millimeters here, and I'm looking for this value. So we have a right triangle. It looks like 12 is my hypotenuse, and then my 2 legs are 6 and x. Okay, so now let's go back and plug it into our equation. So it's going to be leg squared plus leg squared equals hypotenuse squared. So it looks like I'm going to end up with 36 plus x squared equals 144. And after I subtract that, it looks like I'm going to get x squared equals 108. Now, when I take the square root, unfortunately 108 is not a perfect square, but I can factor 108 down into 36 times 3. And then the square root of 36 is going to turn into 6 radical 3. So now I can go back to my original picture, and instead of x, I can fill in 6 radical 3. So I'm going to have that at the top of my rectangle and at the bottom. And this is still in millimeters. So the last thing they want, so they wanted the length, I got that, but then they also want the perimeter. So in order to find my perimeter, I'm going to need to add up all 4 sides. So it looks like my perimeter is going to be 6 plus 6 radical 3 plus 6 plus 6 radical 3. Now obviously I have some like terms, so we have 6 and 6, which gives me 12. But then we also have 6 radical 3 and 6 radical 3, which when I add them up, I'm going to get 12 radical 3. Now, in this case, I can't combine those terms anymore, so that is it for my final perimeter. All right, and then my units, which I'll try to squeeze in right here, millimeters. Now the other option is to change that radical to a decimal and then estimate what your perimeter is going to be, but I can do that at the end and get a more precise answer. For number 6, now I'm looking to find the area of this triangle that I'm given. And I want to write that area in simplest radical form. Now let's just refresh our memory real quick. To figure out the area of a triangle, it's going to be 1/2 base times height. So I'm going to need both of those pieces of information to plug into my formula to figure out what the actual area is. So let's take a look at A. So it looks like I definitely have my height, which is 12 meters. But I do not know the length of my base. Now, fortunately, we are dealing with a right triangle. So I'm going to go through, I'm going to label my sides. Looks like the longest side across from the right angle is that 28 meters. 12 is one of the legs, and x is one of the legs. So let's go through and plug it into our formula. So it looks like I'm going to have x squared plus 12 squared equals 28 squared. So now I end up with x squared plus 144 equals 784. Now, after I subtract that 144, it looks like I'm going to end up with 640. Now, I notice that 640 is not a perfect square, but I do notice that factors of 640 would be 64 and 10. Obviously 64 is a perfect square, so what I'm going to do is I'm going to change that to 8 radical 10. And then my units in this case I was dealing with was in meters. So that's my value for x. So I'm going to go back to my original picture, and instead of x right here, I'm going to write in 8 radical 10 meters. So the last thing I have to do is just plug this information into my equation for the area of the triangle. So I know that the area is equal to 1/2 base, so the base is 8 radical 10, that's what I just found, and the height, which is 12. Now in this case, I'm multiplying all three of these terms together. If you want to, you can just get rid of that fraction right away by just combining those two. Or you could do the half combined with the 12, or you could do all three of them at once. We'll do the half and the 12 together first, just to make it easy. So in that case, I'm going to end up with 1/2 times 12 is going to give me 6. And then I have that 8 radical 10. Now, when I'm multiplying these terms, the radical is going to stay radical 10. I'm really only multiplying those terms on the outside. So I know right away that my final answer is going to involve radical 10 and 6 times 8, which is going to give me 48. So it looks like that's my final answer. Units we were dealing with were meters, and I'm talking about area, so it's meters squared. Now for part B, I'm still looking for the area of my triangle. Triangle definitely looks a little different. Let's just review real quick what we need to figure out my area. So the area is 1/2 base times height. Well, it looks like in this case I actually do have the base, 72 miles, but what I'm looking for is the height. So what is the height of this triangle? So once again, let's just focus on one side, kind of like what we did for the rectangle. So I know we have right angles here, so I'm going to redraw that one down here. Now, this side is obviously 39. They have that marked in my picture. I'm looking to figure out what the height is, so we'll call that x. But the base here is not 72. 72 is the entire base. All right, this is only half of it. And the reason I know that it is exactly half of 72 is because this triangle is an isosceles triangle, which tells me that when I draw this segment down the middle and it's perpendicular to the base, it's going to split that 72 right in half. So that means we're going to have 36 on the left and 36 on the right. So I can fill that into my picture. So it's going to be 36 miles for that one leg. Let's label all our parts. I know the right angle's down here, so 39 is my hypotenuse, x is my leg, and 36 is my other leg. Okay, so let's go through and set up our equation. So it's going to be leg squared plus leg squared equals hypotenuse squared, 39 squared. So I'm going to have x squared plus 1,296 equals 1,521. Now after I subtract that, I'm going to end up with x squared equals 225. And conveniently for this one, once I take the square root, 225 is a perfect square. So x is going to equal 15. Now I can go back to my equation for area. So I figured out that my height is 15 here in this picture. And now I can plug that into my equation. So I know that the area is going to be equal to 1/2 base. So it's the entire base of the triangle, which is 72, times my height, which I just found, 15. Now, as I said, you can multiply these numbers however you want. If you just want to do all three together, you can do that. Or if you just want to focus on taking half of one of the values, you can do that. I might do that from the start just to make it a little bit easier. Since 72 is even, I know that half of that is going to be 36. We actually did that earlier for the base. And now I just have 36 times 15. So it looks like my area is going to equal 540. The units I was using were miles, and its area, so it's going to be squared. So let's take a look at number 7. So what I'm looking for is the base of an isosceles triangle. I'm told it has a height of 10, and the other sides are 22 feet. So let's sketch out a picture of this first. So I'll mark it off as being isosceles. Here is my height. It's going straight down. And then I'll fill in the lengths that they give me. So the height is 10 feet. I'm not going to include the units since I don't have a lot of space. And the other sides are 22 feet. So we have 22 and 22. And I'm trying to figure out, well, what is the base? So maybe we'll call this x right now. Okay, so now I got to figure out how am I going to solve for x. Now let's just focus on one piece at a time. So let's focus on this blue triangle. So it looks like in this blue triangle, I know it's a right triangle. I know my height is 10. I know this side is 22. Is there a way I can figure out this third side? Let's call that y now, since I already used x. Well, in a right triangle, let's label our sides real quick. 22 is my hypotenuse. It's across from the right angle. 10 and y are my two legs. So let's plug these into our Pythagorean theorem. So I end up with y squared plus 10 squared equals 22 squared, my hypotenuse squared. So it looks like I'm going to end up with y squared plus 100 equals 484. And after I subtract that, I'm going to have y squared equals 384. Now, 384 is not a perfect square, but I'm actually going to break this down into square root 64 times square root 6. Square root of 64, that's going to turn into 8 radical 6. So now I can go back to my original blue triangle. Instead of y right here, I can fill in my actual base, which is 8 radical 6. So if I go back to my original picture, the isosceles triangle, what I'm saying now is that we have 8 radical 6 for the base of this triangle, and I'm going to have 8 radical 6 for the base of the triangle on the left. Well, I can do what I did earlier when we were looking for perimeter. I can add these two pieces up, 8 radical 6, 8 radical 6, and together I'm going to get 16 radical 6. How does that help me? Well, what they're looking for is the area. So if I'm going to figure out the area of this isosceles triangle, I'm going to have to do 1/2 base times height. So let's go back and we'll fill in these values, my base and my height. So it looks like my base is going to be 16 radical 6. My height, they actually gave me that, is 10. Once again, it's up to you what you want to multiply together. Sorry, I forgot my equal sign in here. We can do the half with the 16. I can do the half with the 10 if you want to do that. Okay, maybe we'll do the half with the 10, so I know my area is going to equal 5 times, and then 16 radical 6. And once again, remember when you're multiplying and there's a radical involved, you're only multiplying the number in the front. So I'm going to have 5 times 16. So my area is going to be 80 radical 6. And then my units, I was using feet, and they wanted the area, so it's going to be squared. Now our last definition in this section is a Pythagorean triple. So what I'm talking about are positive integers, a, b, and c, that satisfy the Pythagorean theorem. So we actually came across some of these earlier. So let's jump down to this box at the bottom where they give me some examples. So 3, 4, 5 is the most basic. So what you're saying is if I take those side lengths, 3, 4, and 5, put them together to form a triangle, it will be a right triangle. 5, 12, 13, the next one. 8, 15, 17, next one. 7, 24, 25. Now they go on to state that any multiple of those values is also going to be a Pythagorean triple. So like 6, 8, 10. Or you could go with 30, 40, 50. Okay, now how do these triples help? Well, let's say you're given a problem where you have 8 as the height, you have 17 as the hypotenuse, and you're looking for the base. Well, if you recognize that triple as being 8, 15, 17, you're going to know that x has to be 15 right away because that is one of my triples. As I said, the most common and most basic triple is 3, 4, 5. So any multiple of 3, 4, 5 is also going to work. 6, 8, 10. 9, 12, 15 is another one. Any of those would be triples. Any multiples of 3, 4, 5, or multiples of 7, 24, 25, or multiples of any original triple. So how does that play into example 8? So we're given 2 side lengths of a right triangle. Now, all the side lengths are integers. So in other words, they are a Pythagorean triple. I'm trying to find the length of the third side. Now there's 2 options. Either the third side is the other leg, or the third side is the hypotenuse. So let's take a look at A. And let's sketch out the 2 different scenarios in which would take place. So the first one, I'm saying that 24 and 32, they're both legs, and I'm trying to solve for the hypotenuse. The second one, don't worry about B right now. The second scenario would be if 24 was a leg and 32 is the hypotenuse, and I'm looking to solve for the other leg. So what I'm trying to do is I'm trying to figure out in which of these scenarios would x equal a whole number, because that would make the 3 values a triple. So what I'm going to have to do is go through and solve for each of them. So it looks like in the first case, I was saying that x was the hypotenuse. So when I go through and set up my equation, I'm going to have 24 squared plus 32 squared equals x squared. In the second case, I was saying that 32 is the hypotenuse. So when I set up my equation, I'm going to have x squared plus 24 squared equals 32 squared. So once again, I'm trying to figure out in which of these scenarios is x going to be a whole number. So after I square my terms, we're going to end up with 576. 32 squared is going to give me 1024. And this is equal to x squared. I'm using the same terms over here, so it should make it pretty easy. 24 squared is going to give me 576, and 32 squared is going to give me 1024. When I combine my terms on the left, I'm going to end up with 1600, which equals x squared. And when I subtract my terms on the right, I'm going to end up with x squared equals 448. So once again, I'm trying to figure out which one is going to give me a whole number for x. So in which of these scenarios do I actually have a perfect square? So we can go through and check each of them, but it looks like in that first case, the square root of 1600 is going to lead me to 40. So since I got a whole number in that case, I know that is my final answer. So in this case, the third leg that's missing is the hypotenuse. So 40 is the hypotenuse. So what they gave me were two legs. So 24 was a leg and 32 was a leg. So in this case, I really don't have to figure out what the square root of 448 is. I just know that it's not a whole number. So in this case, x could not be a leg. It had to be the hypotenuse. Now let's take a look at B. So I'm going to go through the same steps. Now if you want to, you can just start with 72 and 153 as both legs and try to see if you can solve for the hypotenuse, see if that's a whole number. If you get a whole number, then you don't have to check the second scenario because you already know the first one is right. So for the second one, I'm claiming that, you know what, 153 is the hypotenuse. I'm looking for the other leg. So in these two scenarios, the first one, we're going to have leg squared, 72 squared, plus leg squared, 153 squared, equals x squared. For the scenario on the right, x is one of the legs, so I'm going to have x squared plus 72 squared equals 153 squared. After I square my terms, I'm definitely going to get some pretty large numbers. I'm going to have 5,184 plus 153 squared, which is going to give me 23,409. Then on the other side, I'm going to end up with the same term, so 72 squared, which was 5,184. And 153 squared, which was 23,409. Remember, we have our x squared in here. I don't have a ton of space here, but I do know that x equals x squared. After I add up my terms, I'm going to end up with 28,593. And that's equal to x squared. And after I subtract my terms, I'm going to end up with x squared equals 18,225. Now I'm going to go through, end up taking the square root of both of these terms, and it looks like when I take the square root of 18,225, x is going to equal 135, which gives me the whole number that I was looking for. So in part B, 72 is a leg and 153 is a hypotenuse. And then my other leg is 135. So there's my Pythagorean triple, 72, 135, and 153. Now, if I go back and divide all of these terms by 9, 72 divided by 9, 135 divided by 9, 153 divided by 9, what I'm going to get is 8, 15, 17. So there is my triple.